Today, I'm reviewing a paper where I am one of the co-authors of the publication, and specifically, the paper is about collecting the evidence showing that mRNA-vaccinated individuals are producing IgG4 antibodies. That's the first section of the paper we're going to talk about. And in the second section, we're going to talk about how IgG4 antibodies can be involved in cancer. My name is Dr. Raszek of Genomics, and let's get started on this topic. And I can tell you I'm the first author of this paper. What does that normally mean? It means typically when you publish scientific papers, there's a hierarchy of involvement, I suppose. And the more work an individual has put into a publication, typically they are listed the first, basically. So as a first author, basically it means I have actually contributed the most amount of work to this paper. And that makes sense because if you've been following my videos, you already know that I study IgG4 antibodies in the mRNA vaccinated population to a great detail, and literally every single paper I've studied, I've reviewed, and I made videos on. You can literally see the history of that. And the reason why I was a good candidate for this is because in some of the past videos, you can probably see how I stack evidence, mounting evidence for basically what these IgG4 antibodies have been observed to do and how they function, and basically in what group of people they're observed. And therefore, I was able to lend authoritative voice to this publication. This paper is the first review that summarizes the evidence of observation that IgG4 antibodies against spike protein are being produced pretty much in all of the mRNA vaccinated population, with some exceptions, and we'll talk about that as well. And so it's the first one review of its kind, so that's great. And then we talk about why we should be vigilant and what could we do about it. All right, so let's start breaking this down. Let's talk about the review first, review of evidence. So I can tell you that basically this is pretty much only seen in mRNA vaccinated individuals, these IgG4 antibodies that are targeting specifically spike protein. And it's starting to be observed after second shot, okay? However, after 2 shots, typically you need some period of time before you'll be able to notice these IgG4 antibodies. Usually it takes several months. This can be dramatically boosted if there's another antigen exposure afterwards. And that can involve different formats. That can involve another mRNA shot or injection of any COVID-19 vaccine. So basically, or infection. So that means once you have 2 mRNA shots, your immune system is programmed in a specific manner that any spike protein exposure can then add or contribute to further development of IgG4 antibodies. But it's specifically 3rd mRNA shot that typically see very large, rapid rise in these IgG4 antibodies targeting spike protein. And this is how it was really just observed and documented very well. Overall, in this particular publication, we review, I believe, 15 different reports and scientific publications documenting this. And prior to this being seen in a general population, and I apologize for the wind and the mic, this is why my mic is under my jacket. Because it gets windy here. We'll see if this video will survive because of this. But I did want to show you the amazing view. So before this was observed in a general mRNA vaccinated population, there were individual reports showing that certain people who were mRNA vaccinated developed IgG4 related disease. So it was considered an unusual vaccine side effect. And IgG4 related disease is a condition that individuals can have where they have elevated IgG4 antibody levels. And this was seen that vaccines were either producing this condition or it helped people relapse back into IgG4 related disease symptoms. But now we see that basically this is observed in all mRNA vaccinated individuals. So under what conditions, oh, and by the way, the rate of antibody change can be quite rapid. Once you take the third mRNA shot, you can literally switch your bulk of your antibodies targeting spike protein can be switched to the IgG4 format. And of course, like if you wonder why IgG4, well, we're going to talk about how they can be involved in cancer in this video. I can also tell you that we're already working also on another publication that talks about how IgG4 antibodies could be involved in autoimmune conditions. So stay tuned for that whenever that gets published. This one took a while too. Anyway, so that's basically how and when you see it. So remember, after 2 mRNA shots, any spike protein exposure could boost the IgG4 levels, and that could include any COVID-19 vaccine or even infection. Who's protected though? Who does not seem to be producing this side effect? This very unusual side effect. So number one, individuals who never got vaccinated at all against COVID-19. They don't seem to be producing these IgG4 antibodies. Number two, if you took adenovirus-based vaccine or protein-based vaccine, it seems like those individuals also do not produce these IgG4 antibodies. I believe the 3 vaccines that have been investigated so far are AstraZeneca, Sputnik, and Novavax. Novavax being the protein-based vaccine, okay? So there's that. Next is if you got infected first and then you had mRNA shots, you also seem to be protected. Such individuals do not appear to be producing these elevated IgG4 antibodies, so that's interesting as well. Next is if you took certain immunosuppressive drugs before you took mRNA vaccine, mRNA shot, or gene therapy, whichever you prefer, then you also seem to be protected. So that's also really interesting. And where is my path? And then the next is if you had a combination, if you had 1 mRNA shot and 1 adenovirus-based vaccine, you also seem to be protected. Such individuals seem to only produce very limited amounts of these IgG4 antibodies or not at all. So those basically are conditions that basically seem to be protecting you from IgG4 production. Okay, what we don't know yet at the moment is if individuals were to continue taking mRNA shots, whether that protection would eventually disappear or not. We don't have evidence for that yet. Another thing I can tell you is that right now the limited evidence suggests that Moderna is more likely to produce more IgG4 antibodies than the Pfizer-BioNTech mRNA shot. And that helps to suggest that the reason why this is even happening is because of antigen exposure, too much antigen exposure. Antigen basically is anything that your antibodies target. In this case, of course, the antigen is the spike protein. So the prevailing theory is as to why this is even happening is because too much spike protein was being presented to the immune system after mRNA vaccination. And because Moderna used more genetic material than Pfizer-BioNTech mRNA vaccines, that might help to explain why individuals who took Moderna seem to be producing even more IgG4 antibodies than those who took Pfizer shots. However, there's just limited amount of evidence about that. Okay, so that basically helps to explain why all of this is seen and what is being seen. Now let's talk about the consequences. So I already mentioned that one of these consequences is that, another thing we don't know yet though I should mention is that while yes, IgG4 antibodies against spike protein increase, we don't know yet whether that actually starts to elevate substantially total amount of IgG4 in the body of mRNA-vaccinated individuals. And the reason why we need to be vigilant about that is because if it does, there could be consequences. And we're going to talk about one of those. I mentioned autoimmune conditions, but another one is also cancer. And IgG4 related disease, which is still being diagnosed post mRNA vaccinations in some individuals, that is a type of autoimmune condition as well. So that's at least one potential clinical impact. And we'll talk about that in more detail right away. But another one is, of course, as I mentioned, potentially cancer. So let's talk about the role of IgG4 in cancers. So, well, it happens that there's a lot of evidence and documentation showing that IgG4s can be found in cancers. And when they are found in cancers, typically, and we summarize this evidence in a paper. By the way, this paper is freely available, so check it out. you can judge my writing style. Although multiple authors contributed to this, and typically when you have multiple authors working, different people were responsible for different sections of the paper as well. And then we have one author who was blending it together as well to make sure that it's all cohesive and looks good. So you can be the judge and you can tell me in the comments what you think, okay? So typically IgG4 antibodies are indeed seen in cancers, and when they are seen in cancers that are recurring, for example. Cancers that are coming back are more likely to see IgG4 antibodies in them. Cancers that are more aggressive are more likely to see IgG4 antibodies in them, as well as metastatic cancers, so those that spread from one area of the body to another, are more likely to be accompanied by IgG4 antibodies than non-metastatic cancers. And we provide a wide range of different published evidence to support this. And typically when this happens, this is accompanied by worse prognosis for such individuals, and indeed worse clinical outcomes for such individuals. So involvement of IgG4 antibodies in cancer is not theoretical, it's very well documented. We also talk about hyperprogressive disease, which is basically medical term for what we refer to as turbo cancers. And these scientists that contributed to this article, that's what we call these cancers, turbo cancers. That's not a medical term, but we call them like that amongst ourselves. It's hyperprogressive disease. I started making videos on turbo cancers, so check this out. You'll get excruciating detail showing how IgG4s could be contributing to those specific cancers. And multiple roles are achieved with IgG4s. First of all, IgG4 achieves its function not through the component that targets the antigen, meaning targets the spike protein. That part is irrelevant. Rather, it's through the stalk of the antibody. So remember, antibodies in the letter Y, it's the stalk of the letter Y that is the contributing factor in helping cancer development. It does that by interfering with proper function of other antibodies that would be helping you fight cancer, number one. Number two, it can block certain receptors of immune cells that otherwise would be involved in helping you fight cancer. And number three, it can also interact with receptors that can help certain immune cells switch from one type to another, where they are, instead of being inflammatory, which is a signature of fighting something, your body's, when it's fighting something, it's accompanied by inflammation, to anti-inflammatory immune cells, which is basically what the cancer wants. And there's now an emerging theory that cancers could indeed stimulate IgG4 production in order to hide itself from the immune system. So because of basically these factors I mentioned, it can help cancer literally evade immune system and grow unimpeded. So we mentioned about turbo cancers. We also talk about involvement of these my hair, involvement of these immune cells. They're called macrophages that also play part, and they're switched to either from M1 like to M1 type of macrophages to M2 type of macrophages. Those are the ones that are anti-inflammatory. They might be good for you in other contexts, but not when it comes to dealing with cancer, or M2-like. So, and again, I summarize all of this in those videos dedicated to turbo cancer, so please check that out. And glutathione. Glutathione is an antioxidant that is can also help cancers in certain contexts as well. So we mention all of this. All right, so and then we talk about turbo cancers, and what's the next thing we went after? Okay, oh yeah, and also we also talked about how if you look at cancer samples, they can have B cells that produce IgG4 antibodies in that environment. When B cells are already programmed, I'm just trying to see where my path is, when they are programmed to start producing antibodies, they're called plasma cells. I usually just refer to them as B cells for sake of simplicity, but they're plasma cells. So when you have such B cells that produce IgG4 antibodies in the cancer environment, that is not a good sign. That basically means that it can even has been suggested to use as a prognostic marker of adverse clinical outcomes. Likewise, another process that can be measured is the IgG4 to IgG ratio in cancer, and again, that has been suggested as use of as a biomarker to for prognostic purposes. Basically, again, if your ratio of IgG4 antibodies start to increase in comparison to all IgG antibodies, that's not a good sign. That basically is not good news. All right, so that's basically the summary of how all of this is involved in cancer. But we also talked about another more theoretical component, and that is how spike protein could, through its mimicry of other elements in our body, could also be promoting cancer development. And this is more theoretical. We mentioned this basically to bring attention to this so that this should be investigated further in more detail. And basically, what do we mean? So there are two types of proteins in your body that could be involved in cancer development. There are proteins called tumor suppressor proteins. Those, as the name suggests, will suppress cancer development. But if you break their function, then there you go. You no longer have these important suppressing factors. So they're like the regulators. They can control things. So there is a study, for example, that showed that if you cut up spike protein into fragments, into many, many fragments, then these fragments can mimic something like around 300 fragments found in tumor suppressor proteins. So now you can see if you start producing antibodies against an area of spike protein, that it will also start recognizing tumor suppressor proteins and target those, well, you could essentially remove tumor suppressor protein from function, and then you could be promoting cancer growth. But it's the other way around. You can also have proteins that help cancer growth, and these are oncogenic. So they help cancer development. And specifically, we focused on a protein called galectin-3. So remember, I did a big video explaining galectin-3. This is where I was first being introduced to this, and this was early on when we actually started producing, when working on this paper. And basically, here, why galectin-3? Well, galectin-3 is important in its own right. It plays an important role in many physiological functions, such as cell adhesion, cell differentiation, meaning a cell that can switch from one type to another, as well as angiogenesis, that's basically a buildup of blood network, and apoptosis, cell killing cells. And when you hear all of these together, those are the type of mechanisms that need to be dysregulated to help cancer growth. Angiogenesis, you need new blood vessels for cancer to grow, and so on. Differentiation, so cells can start going from a normal state to abnormal state, for example, right? And galectin-3 plays a role in all of these functions, and galectin-3 has also been seen involved in cancer development as well. And the more galectin-3 an individual produces, you increase the likelihood of seeing cancer-related problems. Now, why do I then bring up galectin-3? For two reasons. Number one is because spike protein actually has a region on it that is nearly identical to a region of galectin-3. And that region, which is the region of galectin-3 that is involved in binding galactose. Now, galactose is a type of sugar molecules, and that's what is believed why spike protein might have copied this in some ancient time, might have literally grabbed that genetic information from a host and incorporated that information into its own genome, so that spike protein could have something that mimics galectin-3. That area of spike protein is called galectin fold, and this might help spike protein attach itself to sugar molecules on the surface of cells. So remember, spike protein, before it enters our cells, it needs to interact with ACE2 receptor, right? We all know this. But before ACE2 receptor comes along, virus could attach itself via spike protein to the surface of the cell with that galectin fold that is mimicking galectin-3, grabs sugar molecules on top of the surface of a cell, and it just sticks around until ACE2 receptor comes along on the cell surface and then can grab a spike protein, and then process continues, right? So that might have been why spike proteins have evolutionary obtained this mechanism. But here we go. It means that spike protein itself could be mimicking something that is already found in our body, and that if there's too much of it, it could be involved in cancer development as well. But besides that, which already sounds bad enough, besides that, another reason why we're interested in this is because of IgG4 related disease. So that condition that individuals can have where they have too much IgG4 antibodies in their circulation. And that's a really understudied condition. This is one of the reasons why IgG4 antibodies in general are so mysterious, because we know so little about them still. And I can tell you that there's very limited number of studies that actually look into what do these IgG4 antibodies in those individuals that have that condition, that have that disease, what do these antibodies actually target? And there was one paper that investigated this, and they tested a number of individuals with that condition, and they found that nearly 30% of all those individuals they looked at, those IgG4 antibodies specifically were targeting galectin-3. So that's the connection potentially between the IgG4 as well and galectin-3. Because possibly what might be happening is that something like galectin-3 might also result in overpresentation of an antigen to the immune system, and you produce IgG4 antibodies as a consequence. But these IgG4 antibodies could then potentially put you at increased risk of cancer development. So of course the next question is, well, are people with IgG4 related disease at increased risk of cancer? And the answer is yes. The scientific literature suggests that that is indeed the case. And one specific meta-analysis that looked into this basically summarized it that meta-analysis is a study that reviews all published literature on a topic, and they combine all of those results to assess what does it tell us in a general term, if I can explain it like that. And that meta-analysis for IgG4 related disease indeed showed that they are at an increased risk for a number of different cancers. And in this review, we mentioned only a couple. One was 4 times increased risk, I believe it was for pancreatic cancer, and 69-fold increased risk for lymphoma. In fact, we actually mentioned that we believe lymphoma will be the sentinel condition to watch out for in the mRNA-vaccinated community, potentially because of these IgG4 antibodies. If these IgG4 antibodies targeting spike protein are a serious issue, then we need to start looking for that condition specifically. All right, so we mentioned that in the paper. So that's the last part that I mentioned in terms of how IgG4 antibodies could be involved in terms of promoting cancer growth. Okay. Now, of course, what we suggest then is, what are the solutions? We're always interested in like, how do we solve these issues? What can we do in order to help the issue? So number one, we call that all physicians should start looking more carefully at their mRNA vaccinated patients for IgG4 antibodies. So we suggest that all physicians start testing their patients who are mRNA vaccinated for this particular side effect. All right, so, and if there are elevated side of IgG4 antibodies, whoa, steep, then what can you do? Well, number one is you could screen yourself potentially for genetic predisposition that could, for those hyperprogressive disease, because IgG4 antibodies might not be enough, at least for hyperprogressive disease. So that's number one. And number two, especially if you might have a genetic predisposition for that, then number two is such individuals potentially could benefit for more frequent cancer screening. Okay, so now what are the levels? This part is we don't know yet, but again, we can go and use IgG4 related disease as a benchmark. So in order for a person to be diagnosed with IgG4 related disease, they need to have at least 1.35 milligrams per milliliter of blood concentration of IgG4 antibodies. Okay, so that's the current standard that is being used. Of course, that's not enough to get the diagnosis. There's other conditions that have to be satisfied in order to obtain IgG4 related disease diagnosis, but that's one of them. So that can be the starting benchmark. However, we do also mention that in cancers that do exhibit IgG4 antibodies, these concentrations of antibodies can even be higher, but they can also be lower than the one we mentioned, right? But at least that's could be a benchmark to start looking at what's happening here. And then we talk about, only unfortunately very briefly, about treatment options. The reason why unfortunately is because this part of the paper did not survive editorial review. So this section was much bigger, and we basically had to cut it down. So we trimmed it a lot. Now, in terms of how to deal with IgG4, I did a video on that as well, so check that out. And I'll be making more now based on the information that was unfortunately removed from that article. But we did talk about that there's ways to target IgG4, there's ways to target glutathione. And one example that I mentioned with glutathione is increased concentrations or use of high concentration of oxidized vitamin C. Why? Because oxidized vitamin C will remove glutathione, and that has been, we brought up one example where that was used successfully to treat a cancer, but it was under specific genetic background. But we do mention that there is methods of trying to deal with glutathione, and there's also methods of dealing with macrophages so that you can switch them back from that M2, undesirable M2 type, back to M1. And So, like I said, I'll expand on that in a future video as well. And yeah, basically that brings the summary to an end. It's and what we also mentioned is that when it comes to the vaccine makers, it's important to now start studying what are the appropriate amount of antigen that should be delivered in order not to trigger IgG4 production, and as well as mechanism of delivery. And we also just published recently another article that discussed this as well, how the chemical composition of the vaccines could have been contributing as well to IgG4 production. So check that out as well, all right? And how that, besides IgG4, how the chemical composition of mRNA vaccines could also be at risk of helping cancer growth once there is cancer. All right, so that's basically in a nutshell the review of these IgG4 antibodies. What we're seeing post mRNA vaccination, as I mentioned, first big summary of what has been reported in the last almost 3 years now, but really this information is now coming out at an increasing speed, and we thought it's time that a review of already current evidence is needed so that the awareness of this taking place can increase. All right, I'm gonna wrap it up here. And I'm not sure if you can see the big fire there on the horizon behind me. Not good. But hey, please leave a comment. Let me know what you think about either the article or the video. And I hope you check out the article as well. It's not long. Like I said, it got trimmed a lot by the editors. Oh, and speaking of editors, I gotta tell you, we accidentally were about to make a big mistake, and one of the editors saved us from embarrassment. Like, accidentally, we put a mistake in a paper that something we all knew about, and it just went over our heads. And one of the editors saved us from embarrassment, so thank goodness. It happens, you know. Obviously, it happens when you're working and you're summarizing scientific evidence. Mistakes can always creep in, so I'm glad we had good editors who really not only did they grill us, but they also helped us to make sure that the accuracy of the content is good. So that's awesome. And also, please subscribe to the channel if you haven't already. That's how we grow. And please share the video as well. You know that both us and YouTube likes it. And finally, also check out our Patreon account when we make additional content that doesn't make to the YouTube. And I look forward to seeing you in another installment. Bye, everyone.